like to discuss division of polynomials, and that's dividing one polynomial by another polynomial. And we've been talking about this in class using polynomial division techniques and looking at how that works. I want to look at a general form of a problem and see if we can't begin to develop some patterns and see if in fact we can generalize those patterns. Hopefully at some point I'd like to have you attempt to write a basic computer program that divides polynomials. Okay, now with that in mind, let's look at this example right here. I want to take this numerator polynomial and divide by this denominator polynomial. In the numerator, I have a second order polynomial, a sub 2 x squared plus a sub 1 x plus a sub 0. A sub 2, a sub 1, and a sub 0 are the coefficients, a sub 2 being the coefficient of the x squared term, a sub 1 of the x to the 1 term, and a sub 0 the constant. I want to divide it by b1 times x plus b0. Coefficients have a similar format to the numerator. Okay, using the polynomial division approach, you can write something like this. What I want to do is to divide this polynomial into this polynomial. Well, using the techniques that we've developed when these things are numbers, we see that what we want to do is we want to find the term, which is this term, that multiplies this term right here so that the coefficients become the same, so that when we subtract them, we get 0. And it turns out that the term that does that is a sub 2 divided by b1 x. If this multiplies b1 x, the result is a sub 2 times x squared. And then when this multiplies b0, we get a sub 2 divided by b1 times b0 times x. So then we subtract this whole term in red from this term up here in white. When we do that, these two terms cancel out. This cancels out with that right there. And we end up with a sub 1 minus a sub 2 b0 divided by b sub 1 all times x. So this is what this term becomes, and then we bring the a sub 0 down. And so now we want to find the coefficient that multiplies this, that gets rid of this term right here. That coefficient is this one. This whole thing in green, when multiplied by b1x, gives me this term. It gives me a1 minus a2 times b0 divided by b1, and then times x. Now this term, when multiplied by b0, gives me this right here. Okay, this is b0 divided by b1 times a1 minus a2 times b0 divided by b1. Now I subtract everything in yellow from everything in green. Okay, this term cancels, and I get a0 minus this whole thing, which is b0 divided by b1 times a1 minus a2 times b0 divided by b1. So this is what I get when I do this whole synthetic division, where I get this up here as the quotient, and I get this whole thing down here as a remainder, which I've rewritten up right in here, where I say, okay, this is the remainder term, this is the quotient term right here, okay, and this is the remainder term. Now at this point, I would challenge you to begin to look for patterns in these terms. I think you might see a pattern already beginning to emerge here in the remainder, where we have a0 minus a1 times b0 divided by b1 plus a sub 2 times b0 divided by b1 quantity squared, and so on. If you look a little bit harder, you might begin to see some patterns developing here in the quotient term. But I don't want to dwell on that too much right now. But what I do want to do is to give you a problem to look at. And that problem is I want you to do a division like this, except what I want you to look at is a third order polynomial in the numerator. So I want you to look at a sub 3 times x cubed plus a sub 2x squared plus a sub 1x plus a sub 0, and take that and divide it by b1 x plus b0. So I want you to do this as a homework problem and see what you get for the quotient in that case, and for the remainder. Okay? Till next time.